Hi, we are going to talk a new chapter, electrostatics, otherwise known as static electricity. Charges, we are going to talk completely about types of charges, storing of charges, based on the charge, what is called electric field, what is called torque experienced, then what is called a capacitor, etc. Charges cannot be produced. Charges only can be transformed from one body to the other body. Charges can be transformed. In that sense, when you rub a glass rod with a silk cloth, glass rod rubbing with silk cloth, ebonite rubbing with fur, there is a charge transformation. So glass rod, when it is rubbing with the silk cloth, glass rod loses a negative charge. Thereby it becomes positive. Silk cloth acquires that negative charge. So electrons gained by the silk cloth, which is lost by the glass rod, gained by the silk cloth. So this glass rod, when you consider, after rubbing with silk cloth, it becomes positive because negative charges transferred the silk cloth. Two such glass rod you take, bring it closer, it will repel. That means like charges repel each other. Unlike charges will attract, like charges repel. So these two glass rods try to move away. Okay. Similar case happening in the case of ebonite rubbing with fur. So this charge, of course, glass rod is electrically neutral. Silk cloth is electrically neutral. After rubbing, this charge transformation takes place. Then, what are the basic properties? Properties of the charge. What is the meaning of it, sir? Properties of electric charge. Electric charge means we call it as charge of an electron. 1.6 10 power minus 19 coulomb. That is the charge of the electron. Okay. Basic three properties we have. Quantization of electric charge, conservation of electric charge, additive nature of electric charge. Quantization, conservation, additive nature. Quantization means, see the word quanta. That means charges are executing in terms of multiple, it is the internal multiple of a charge. A body is charged, meaning the total charge Q will be Ne, where N is an integer, plus or minus E, plus or minus 1E, plus or minus 2E, plus or minus 3E. Negative charge for the electron. Quantization. Conservation means total charges in the reactant side and product side will be equal. Chemistry you are studying, balancing the equation. The amount of charge in the reactants and the products are equal. That is called conservation of electric charge. Atom is electrically neutral, has got equal number of protons and electrons. Additive nature of electric charge. Suppose you are adding two charged bodies, 5 coulomb plus 3 coulomb, 8 coulomb minus 5 coulomb, 6 coulomb minus 2 coulomb, 10 coulomb plus 4 coulomb. This is called additive nature. Here you are putting minus sign also. Here also we are adding two charges when it is added up. One charge is positive, another charge is negative. Then positively charged body, negatively charged body. 8 coulomb plus of minus 5 coulomb, that is the meaning. 8 coulomb, 3 coulomb, 4 coulomb, 14 coulomb. Example. So this is additive nature. Additive nature of electric charge. Okay, fine. So keeping this introduction in mind, we'll go for Coulomb's inverse square law. Coulomb's inverse square law. In the case of Coulomb's law, consider two different charges, Q1 and Q2, separated by a distance R. These two charges might be positive, one charge positive, one charge negative, or both charges can be negative, we don't know. Inverse square law already we have learned in Newton's law of gravitation. Here, similar to that, there exists a force of attraction if one positive, one negative, or repulsion, both are negative, both are positive. Force of attraction or repulsion between the 2 point charges, which is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. F proportional to Q1, Q2 by R square. Or F is equal to constant K Q1, Q2 by R square. Force is a vector, so I can put R cap. Charge is measured in coulomb. This is a distance. So right answer also should be a vector. So we are multiplying by a vector quantity. This K is nothing but 1 by 4 pi epsilon. 1 by 4 pi epsilon. Epsilon is nothing but epsilon naught into epsilon r. Epsilon we call it as permittivity of the medium. Epsilon naught, permittivity of free space, or a epsilon r, relative permittivity. Epsilon r is nothing but epsilon by epsilon naught. You are saying epsilon is equal to epsilon naught into epsilon r. So epsilon r is nothing but epsilon by epsilon naught. It is a ratio, so no unit for relative permittivity. Epsilon naught is a constant. Its value 8.854 into 10 power minus 12. We have to put the unit. We will put. Suppose you are working in an air medium. For air medium, epsilon naught value is 1. Relative permittivity is 1. Therefore, the epsilon is equal to epsilon naught. So, in that case, if you talk the force, that is F air is equal to K. K is nothing but 1 by 4 pi epsilon naught, because epsilon naught becomes 1. 1 by 4 pi epsilon naught Q1 Q2 by R square R cap. Force experienced by charge 1 with respect to charge 2. Force experienced by charge 2 to charge 1. 1 to 2, 2 to 1. Definitely these two are opposites. This force and this force opposite to each other. Opposite means you have to put a negative. No, sir, like this. It is repelling. That is force of repulsive force. Listen. Force experienced by charge 1 with respect to charge 2. Force experienced by charge 2 to charge 1. Opposite direction, so we are putting minus. This is called repulsive force. That direction is different. Two charges repel, that indication. Okay. Now we have to write the unit of epsilon naught. Epsilon naught, you take it here, bring F here. What will you get? 1 by 4 pi F Q1 Q2 by R square. Q1 Q2, what is the unit? Coulomb square. By F R square by Newton meter square. Numerator will become Newton power minus 1, meter power minus 2. Don't mug up. Just from the relation, you find the data. 8.854 into 10 power minus 12 Coulomb square by Newton meter square. It's a unit. Fine. 1 Coulomb. We need the definition of 1 Coulomb. What is the meaning? If Q1 is equal to Q2 is equal to 1 Coulomb, R is equal to 1 meter, then force F is equal to 1 by 4 pi epsilon naught 1 into 1 by 1. One by 4 pi epsilon. So 1 by 4 pi epsilon naught alone. Actually 1 by 4 pi epsilon naught, you substitute epsilon naught value here. 8.854 10 power minus 12. Simplify. Denominator 4 into 3.14 into this value multiply 1 by that value calculate. You will get 9 into 10 power 9. Problems, it will be helpful. 9 into 10 power 9. Newton, because left hand side is forces, so Newton. Sir, 1 by 4 pi epsilon naught, what is the unit, sir? Epsilon naught unit is Coulomb square by Newton meter square. So 1 by epsilon naught unit will be inverse. Newton meter square per Coulomb square. That is the unit. Correct? Okay. So 1 coulomb is defined as the strength of the force which one placed at a distance of 1 meter from equal and similar charge placed in air or vacuum, because you have done epsilon naught, placed in air or vacuum, experience a repulsive force of 9 into 10 power 9 Newton. Why repulsive force? Equal and similar charge. So the word repulsive force. This is state and explain Coulomb's law. Sir, Coulomb force, gravitational force. I know already gravitational force. Now you have told Coulomb force. What is the difference? Gravitational force is only attractive force. F is equal to G, capital G, M1, M2 by R square. Attractive force. Here, attraction or repulsion. Number 2, gravitational constant G is 6.67 10 power minus 11. Whereas K, 1 by 4 by epsilon naught is 9 into 10 power 9. Very high value. Coulomb force is depending on the medium. Air medium, it is epsilon naught. General medium means epsilon naught and epsilon naught. But their gravitational force is independent of the medium. So 3 major difference we have between Coulomb force and the gravitational force. Okay, fine. Electric field. Gravitational field means it is a region around which gravitational influence can be felt. So any body, if you want to project outside the gravitational field, it means that is called escape speed, escape velocity. You have to project at a velocity of 11.2 kilometers per second for the body to escape outside the gravitational field. You have a magnet surrounding, there exists a magnetic field. It is a region. When you bring any small iron piece closer to that, within that magnetic field, if you bring it, will attract. Similarly, you have a charge Q. Let it be as it is. I have another charge known as test charge, whose magnitude is very, very small. Very small. Compared to this charge Q, the test charge magnitude is very small. You are bringing that particular Q naught closer to Q. At one particular point, it starts repelling. At one particular point, it is repelling. Why? Both are positive, so there exists a repulsive force. So this distance, you take it as a radius, draw a circle. This is called electric field region. The region around which electric influence can be felt. Some other charge you have to bring. So the force experienced per unit charge, we call it as electric field. E is equal to F by Q naught. Unit wise Newton per Coulomb. E is equal to F by Q naught. Clear? Electric field due to a point charge. Sir, I have a charge Q and Q naught. Electric field, this is positive. So away. Distance between the two charges, you take it as R. By Coulomb's law, you calculate what is the force. F is equal to K Q1, not Q1, Q0 by R square. E is equal to F by Q0. So I can write KQ by R square. 1 by 4 pi epsilon naught Q by R square. Electric field due to a point charge. Here Q0 magnitude is very, very small compared with Q. Why it should be small, sir? What is the meaning? When you bring the charge Q0, it should not affect the originality. Original charge Q has got an electric field. More electric lines of force are coming out. It should not be disturbed by the movement of this Q0. This is, say, 1 coulomb. This is 100 microcoulomb. Very small. Then only it will repel. By bringing Q0, Q should not be affected. So only we call this as test charge. Okay, fine. What is called electric lines of force, sir? What is the meaning? You told something about electric lines. What is the meaning? Properties of electric lines of force. You have plus Q charge, direction of electric field is away from positive. Away from positive. Minus Q charge, direction of electric field is towards negative. It can be isolated. Plus Q separately, minus Q separately. No, sir. Positive to negative only. You can electric lines originate at positive, terminate at negative. Originate at positive, terminate at negative. Lines of force are crowded. Lines of force are crowded. It will never intersect. It may be crowded, but it will never intersect. Electric field is more there. More lines of force you will have, but it will not intersect. Direction of tangent will be direction of lines of force. What is the meaning? Sir, lines of force are curved. You told this is curved. Straight line means I know the direction. Curved means which direction it is going, how do we know? For that, what we have to do is, which point you need electric field? I need electric field at this point. Draw a tangent. Direction of tangent will be direction of lines of force. Here I want that. Draw a tangent. Here, draw a tangent. So direction of tangent will give you direction of lines of force at that particular point. More lines of force. Lines of force are far apart. Electric field is large. Electric field is small. E is large, E is small. Small means lines of force are far apart. Large means lines of force are crowded. So these are the few points of properties of electric lines of force. Properties of electric charge is different. This is lines of force. Okay. Next, electric dipole and dipole moment. Two equal and opposite charges separated by a distance, small distance, 2a, 2d, 2r. Anything. Why 2d, 2r? d, r, a we can take to that. For mathematical calculation purpose, we are taking this distance as 2d. Distance into the magnitude of charge, we call it as dipole moment. So dipole moment is the product of magnitude of any one of the charge and the distance between them. Q into 2d. We call it as electric dipole moment. Okay. From the center, this is D, this is the B. Okay. Now we have to calculate this electric field due to this dipole along axial line. Electric field at a point along the axial line of a dipole. What is the meaning? This is a dipole, minus Q plus Q. At this point P, we have to calculate the electric field. No, sir. s.e.a. will take. No problem. AB, center O. Point C, we have to calculate the electric dipole. Electric field at this point C due to this dipole. So, due to positive charge plus Q, what is the formula? For a point charge, the formula of electric field is Q by 4 pi epsilon naught R square. Q by 4 pi epsilon naught. The distance between these two is BC square. Similarly, for minus Q charge, Q by 4 pi epsilon naught AC square. Sir, minus we have to put no, sir. No. Electric field is a vector. So, depending upon the direction only, we have to put plus minus, not because of the magnitude. If it is a scalar quantity, you can put plus Q means plus Q, minus Q means minus Q. We are going to discuss. The distance between minus Q and plus Q is 2D. O and C, the distance, let us assume R. So I can write Q by 4 pi epsilon naught. BC square is nothing but OC minus OB. OC minus OB means R, this is D, this is D. So I can write R minus D the whole square. This is Q by 4 pi epsilon naught. R plus D the whole square. So resultant electric field, how to calculate that? Plus Q charge, direction of electric field is away from positive. Minus Q charge, direction of electric field is towards negative. So the resultant electric field along axial line will be E plus of minus E minus. Why we are putting minus sign there? Opposite direction. So I can write for axial line Q by 4 pi epsilon naught is common term. I can take 1 by r minus b the whole square minus 1 by r plus b the whole square. Rearrange r plus b whole square minus r minus b the whole square whole divided by a minus b, a plus b, a square minus b square whole square. Rearrange, you will get the resultant electric field along axial line is 4qd by 4 pi epsilon naught r square minus b square the whole square. 2q into 2d by denominator. Q into 2d already we have learned. Electric dipole moment P. So instead of Q into 2d we can substitute electric dipole moment 2. So 2p by 4 pi epsilon naught r square minus b square the whole square. Of course, 2q into 2dr you will get. You simplify and rearrange, you will get like this. But the distance between minus q1 by plus 2d is very short. 2d. 2d itself is small. So d will be very small compared with this r. Whenever you talk, one value is less, you have to compare with another value. Then only you can say this is small compared to that value. So compared to r, d is small. Neglect d square. So d square neglected means r square the whole square will become r power 4. 1 r get cancelled. You will get 2p by 4 pi epsilon naught r cube. This is electric field due to a dipole along the axial line. Sir, what is the direction, sir? Positive charge direction is along BC, B to C. Negative charge electric field direction is towards C to A. Out of BC and CA, electric field, it is greater for plus Q or minus Q. Plus means it is Q by 4 pi epsilon naught r minus P the whole square. Denominator is less. Total value is more for E plus. Minus charge, denominator is r plus d the whole square. Denominator is more. So total value is less. So the resultant electric field will be along the direction of positive side. That is along BC. Okay. So 2p by 4 pi epsilon naught r cube, direction along BC. Now we are going to write electric field at a point along equatorial line of a dipole.